We sound ready. Okay, good. Big round of applause for Edward, please.
Hi, I'm Marius. I'm the CTO of reinfer. We're an AI startup working on conversational interfaces. Tonight I'm going to demo a tool that allows you to build a text classifier extremely easily with just a limited amount of data. This is something you may want to do if you have a lot of textual feedback, say, about your product, and you want to find out what people think about it, what bad things they think, and what feature requests you may want to have. For instance, reviews for an app, or if you're a retail website and you've got post-purchase questionnaires, or just in general what people say on social media about your product. So here we've got datasets. A dataset is essentially just a collection of short pieces of text. They can come from wherever. And you can, this is just a random sample of tweets that mention Tesco, for instance. And these are suggested labels, so each particular text can have labels. And this is essentially a random sample of labels that you're allowed to, you can label. One key feature of this product is that the universe of labels is completely user-defined and dynamic. So if I want to create a completely new label that was never used before, I can just do that. And each label also has associated sentiment. So for instance, this is negative, it's a negative general comment, and this is positive about promotion. If you want to create a new label, you just assign it. And the underlying machine learning algorithms gets trained and suddenly knows about this label. After a few tens of examples, you get pretty good performance. So in our experience, you can get past 95% accuracy with just tens of examples. So here these are all the labels that were assigned in this particular dataset. So for instance, these are comments labeled with customer service, so everything to do with customer service. If you have a certain hypothesis, let's say we want to see what people say about the driver's behavior, the people who deliver Tesco groceries. So let's say delivery driver behavior. Right, so for instance, we've got semantic search. So the idea is that this tries to figure out the meaning of the sentence rather than just matching words. So the first comment that comes up is this person complains about the driver, but at the same time says something positive about the customer service lady. And I mean, the first two predictions are, instead it's negative about delivery, but it's positive about customer service. And we always show just the top three labels. These are assigned labels. And so let's say you've got a collection of pieces of text and then you label them, spend a few hours doing it. Actually, all of these tweets you've done a few hours before the demo. And once you've got a few hundreds of them, you want to essentially run the model on all of the comments from the beginning of time and see if there are any trends. So we built essentially a tool that summarizes all of the predictions. So essentially, it runs the model on all of the tweets. And so we've got 400,000 tweets. We only assigned 500. But because the model learned how to assign labels, it can actually say the right number of labels for all of these tweets should be 13,000. And this quickly allows you to identify trends, for instance. So here it's a bit sparse. We only have a few tweets in the beginning, so that's why it looks like this. Actually, we've got a better data set I've done, not before the demo. So this is a post-purchase questionnaires for a retail website. And these are the top labels predicted by sentiment, for instance. And maybe you're interested in just the period in the last few months. And maybe we only want things that are negative. So only negative comments. And these are the predicted negative comments. So what's actually assigned is quite different. We can also download all of the raw data, which if you want to join it with whatever data you may have and want to do A/B tests. So for instance, say I created a new feature, I want to see how people reacted to it. You can see what the net sentiment would look after I release my feature. Let me clear this. So let's say I made a change to shipping costs. and I want to see what happens. So this would be the net sentiment for the shipping costs, which, oh, this is, yeah, not sure what happened here. So, I mean, the basic idea is that it allows you to quickly run hypotheses. So if you've got a hypothesis about your data, you say we released a feature at a particular date, and you want to see what happened with packaging, for instance, at that date. And if you can't do it here, you can download the data and do it on raw data. So I have a few questions for you. It's still slightly work in progress, but I'd be very interested where you'd see this useful, and if you're particularly interested in any integrations, like imagine you could integrate this with Google Play Store, so you could pull all your reviews and you can see what people are talking about, or similar with Twitter, as I demoed the Twitter dataset. Thank you.
Cool, well done.
Hi. I think it's a really good idea. I used to work in market research and I would kind of take lots of text from questionnaires and try and theme them. So I think this is really useful. So are you trying to turn qualitative data into quantitative data? And if a client was trying to look at some information, would this complement qualitative data, or would it completely replace it? Or how would it fit in with the actual comments which are being made? Because I would think to present something numerically, you would run it through a data processor, but you've completely taken the language and the text and the comments completely out of the equation here. So as much as I like it, where do the comments actually fit into this product?
These are labels applied to each comment, and you can come up with whatever taxonomy you want. So you may, if what I'm interested in are product features, I can quickly go and label 100 comments about product features. And that 100 comments may be a very small percentage of all your comments, but because the underlying model learns very quickly, you can then go and see whatever trends may exist, historical trends over like 1 million different comments. That's exactly right. But the actual categories are completely dynamic, and you can create them and modify them on the fly, and the model gets updated every time when you do that. So the taxonomy is user-defined, so there's no built-in taxonomy. When you come to, so that's what I was trying to show. You can create your own labels and say this is like a negative label. It doesn't matter what they are. Like when you start with a new data set, no labels, and the taxonomy is defined by you. Does that answer your question?
Any more questions? Yes.
Would people be able to export the data? Like, could you build an API that would allow you to access the information there?
Actually, we only have, the API is the main thing we had, so this is very much aimed at developer and people who'd like to use it as an API originally. Yes, so the way to push the comments to a data set right now is only via an API. So we do have an API. And also you can download everything as a CSV if you want all of the predictions. It's just the raw data that gives you a Excel file in which each row is a comment, and you have probabilities for all of the different comments and also the associated sentiment.
Could you talk a little bit about the different? Because I've seen sentiment analysis of certainly of Twitter data before. So is this doing something different, or what's the unique, the USP, if you like?
So it's not just for Twitter data; it's in general for text. We're very much. I mean, the company was founded by there's 3 of us. I'm one of the founders, and we did it as part of our academic research at UCL. So it's the actual models that you use, the underlying models. I don't know how much you know about deep learning, but they're very new models developed in the last few years, and they're very different from traditional models in that you can get a good classifier with a tiny amount of data. So if you were to do like some more traditional machine learning, you may need hundreds of examples. Because of the underlying models, you can get the same performance with just 30. That's one of the maybe key features of it.
Hi, where is the product picking comments from? So for example, if I am running a hotel, I might want to pick comments from TripAdvisor or Expedia or Booking.com or Twitter. So how does that work?
So that's exactly my question about integrations is what what services would you find useful to be integrated with this? So right now, there's just an API. So when you create a data set, you have to manually push the comments via the API. So it's essentially your job to download them from TripAdvisor and push them into a data set. We're very much interested in building integrations. So Google Play Store was one idea, TripAdvisor is a great idea. So it should just be a matter of saying, sign in with TripAdvisor, and then we pull all your comments. Well, for instance, if I can put the question back, what integrations do you find useful? Apart, so TripAdvisor, say. But.
So, like I said, if I mean, I work in the hotel industry, so hotels it would be TripAdvisor, Expedia, Booking.com, their own Twitter handle. At least these are the basic places to start.
Fair enough.
So, can you talk a bit about how you can enrich this data? For example, can you add location, or so that way, if you're talking about a chain, I can know which branch it's associated with, stuff like this?
Absolutely. We'd like to, there are a few different dimensions we'd like to enrich it along. So one of them would be the source. So a particular data set, the actual comments in the data set can come from multiple sources. So maybe TripAdvisor is one source, and that should be exposed here. Maybe you want to see statistics by source. Let's see how the reviews on Booking.com compare to TripAdvisor and so on. We're also very much interested in supporting conversations, so each comment could be a conversation. So for instance, for Twitter, it won't just be the text of a tweet, but it'll be a Twitter conversation. And maybe you can label individual pieces, individual tweets in the conversation.
So, can you go first? Yes. Great idea.
Thank you.
Always have I do a lot of work in consulting, and you always have a lot of issues analyzing data, and you always do a little bit of that and move into the quant, but no one's actually I've seen solve this really well. So I think that's really good. Two questions. First of all, how much of the data, what proportion of data you need to label manually before the predictive mechanism works accurately? First question. And second question, to answer your question in terms of who do you want to integrate to, I suppose the question is back to how are you looking to monetize this? Because that determines what's your route to market. Are you looking at like hotel industries? Are you looking at consulting? Or that really would determine what API you need to develop for the data to come in.
Great questions. So the first one about how many data points do you actually need to get decent performance is not a lot. So for these are post-purchase questionnaires. It's actually real data. Do I have it in order? It's tiny bit slow, but. So, for instance, for this taxonomy, we saw that it's enough to have around 30 to get 95% accuracy for that particular label. Literally, for the Tesco dataset, we've done it in 2 hours before we came here. So not a lot, in the tens. Sorry, your second question was about... Yeah. So, how we monetize it and how we're thinking of monetizing it. So we went about just going and talking to big retailers and selling the tool. We're also very much interested in opening it up as a developer tool with maybe a free tier of up to X number of comments. You can just use the API, submit it, and then if you have more than that number of comments, you have to pay per transaction or something along those lines. It's still debated.
Thank you so much. Big round of applause, please.